Good evening everyone. I am Shruti Joshi from the team Deep Drawing, and let me introduce my team members: Sneha Pandey, Akanksha Nayak, Amisha Raut, Parvati Sharma, Nitin Aryan and Ajit Kumar. Moving on, let me discuss about anisotropy in deep drawing. Because of planar anisotropy, the sheet metal may be stronger in one direction than in other directions in the plane of the sheet. This causes the formation of ears in the upper edge of a deep drawn cup, even when a circular blank is used. Anisotropy in blank sheets is usually the result of a large deformation during initial processing operations. This anisotropy, prevalent in the pre-processed sheet segment, influences subsequent deformation, such as deep drawing. It dictates the shape of the yield surface and strongly affects the strain distribution obtained during metal forming. Finite element simulations of metal forming provide an effective means to investigate relationship between processing deformation and structure of material, and therefore useful guidance in fine-tuning production processes. In addition, the formability and the failure patterns of welded blanks can be accurately predicted with appropriate draw restraining forces and material properties. Applications of finite element methods to deep drawing analysis with the aim to better understand the forming processes enables precise designing of sheet metal parts, the tool, and various forming processes. Many studies have been undertaken to determine the formability of welded blanks using standard tests. However, very little information is available regarding the effect of anisotropy under complex stress-strain states, such as that occurs, for example, in a square cup. Over to next.
Thank you, Shruti. Moving on to the next topic, material flow in deep drawing. So in this deep drawing, with or without draw bits, a blank holder restrains the sheet metal blank at its periphery while a punch forces the metal to flow into the die cavity. The equality of the formed part is determined by the amount of material drawn into the die cavity. Excessive material flow and low blank holder force may cause wrinkling, and insufficient material flow will cause excessive thinning, which can cause tearing or fracture, obtaining a wrinkle-free part, and the desired percentage of stretch in a deep drawn part sometimes can be very frustrating and time consuming. Wrinkles, fractures, loose metal buckles and oil canning are everyday problems in the die build and stamping industry. Addressing these difficulties requires a good understanding of metal flow and how it is affected by draw bits, step bits and drawbars, as well as the effects of part geometry. All too often, draw bits are used in an attempt to obtain stretch and reduce wrinkling when the basic part shape is not conducive to stretch and could be altered without affecting fit or function. Successful stretch can be obtained through the use of draw bits, drawbars and changes in part and addendum geometry. Understanding the basic principles of obtaining stretch and eliminating wrinkles can prove to be most valuable when troubleshooting drawn parts in high-strength, low-ductility materials such as advanced high-strength steels and aluminum alloys. Forming a complex geometry requires precise control of material flow into the die cavity. This control can be achieved using spacers with a specific height or a CNC system to deliver constant or variable BHS. Thank you. Over to next.
Thank you, Amisha. Deep drawing is suitable for a wide variety of materials including stainless steel, aluminum, galvan, nickel, silver and brass, giving customers a wide variety of choice of material to suit their components' needs. The typical flow behavior of iron and steel is determined from a tensile test. This linear regime of deformation is interrupted in a tensile test by the onset of geometric instability that is given by the Hart's criterion, where d sigma upon d epsilon is work hardening and sigma is stress. The main factors discussed are draw ratio, the blank holder force, the metal's value, the frictional values. Great difference in metal flow patterns can result in an imbalanced flow. Excessive imbalance can cause product problems such as oil canning or loose metal in the straight walls of a square-bound shell. Severe imbalance problems can result in curved vertical and horizontal walls. The addition of draw bits can help overcome these differences by slowing down the metal feeding in the side walls, reducing the probability of problems. This is a very common practice and helps to balance the feeding from the corner to the side wall. Draw beads create a restraining force by forcing the metal to bend and unbend before entering the draw cavity and punch. Over to Ajit.
Thank you. Let's get to the conclusion. As the control of material flow by use of textures, in drawing test, it is shown that the friction can be influenced by the use of the rolled textures. So by transferring these, the material flow is retarded in desired areas. Hereby, the form of the flange area is affected positively. The influence of the anisotropy is counteracted, and more round flange of the deep drawn cup parts is realized. In this connection, especially open textures are particularly effective. And by an additional texturing of the blank holder, this effect could be further increased. So in summary, we can say that the texturing by rolling is a promising approach as an alternative to the use of draw bits. One advantage of this technique is especially the high flexibility, since the number, distribution, depth and width of the textures can be adapted to the particular requirements. That's all from our side. Thank you.